Hey, hi guys, welcome back to my channel ITTECHSTACKS. This is Amar Gajare, your cloud instructor. So, in our last module, we learned about Google Cloud Platform, all basics about Google Cloud Platform and its features. Okay, so this module 2, we learn about Virtual Private Cloud, is also called as VPC. Okay, so let's begin with VPC. Before that, we'll see what all subtopics we are going to cover in this module. Subtopics are like virtual private cloud networking, compute engine, scaling virtual machines, VPC and compatibilities, load balancing, cloud DNS, and cloud CDN. Later part, we will go through some lab exercises and so on. So, what is virtual private cloud? So, before we describe about virtual private cloud, each and every Google Cloud project have a default virtual private cloud. Okay? Whenever you open a GCP console and if you go to virtual private cloud section or VPC section, there you can see a default VPC created. Okay? So virtual private cloud can be a custom VPC or can be a default. You can create your own VPC or with your own configurations, or by default GCP provides default VPC. Okay. So what is virtual private cloud? Virtual private cloud is a secure individual private cloud computing model hosted within a public cloud. So what do you mean by hosted within a public cloud? So GCP Google Cloud Platform itself hosted on a public cloud. What do you mean by public cloud? So all the resources and services of GCP data centers are deployed across different regions, different zones, and they are interconnected to a very high bandwidth cable, internet cable, or you can say public internet cable. So that's why it's called as public cloud. Whereas VPC, you can create your own private cloud which is private to your project or private to your department, private to your purpose. It's called virtual private cloud, and it is secure because it is only you and your team members can access this secure VPC, and it is private to your computing model. So what all things you can do to VPC? Like any other private cloud, here you can run code, store data, host websites, and can do anything else that can be done through an ordinary private cloud. Second thing is a virtual private cloud is hosted remotely by a public cloud provider. So this is the two features we have for a private cloud, virtual private cloud. Okay. So virtual private cloud, first Google Cloud project or by starting with a default virtual private cloud. So what is virtual private cloud? I believe everyone understood that one. This part we discussed just now, and this is the public cloud where all the resources are accessed or common across different projects. Okay. So what is VPC? We are talking about VPC, Google Cloud VPC. Okay. Google Cloud VPC is a private cloud hosted remotely by a public cloud provider. What do you mean by that? This means the VPC combines scalability of the public cloud, okay, with computing with data isolation of private computing VPC network. Okay, so VPC, it's hosted on public cloud but maintain the privacy and secrecy whatever private cloud maintains. I hope that clarifies. Okay, let's go on. So here are some of the VPC features. VPC network connect Google Cloud resources to each other and to the internet. Okay. So VPC network connect Google Cloud resources to each other and to the internet. So VPC can create a network within your private cloud, or you can do an interconnect between different cloud networks. Okay. So it's having a segmenting network feature, different segmenting features or nets we have. Third one is it uses firewall rules to restrict access to instances. Okay. If you don't want to provide accesses for any of the instances or users or any resources, you can set up a firewall rules for your VPC. Okay. So creating a static routes to forward traffic to specific destination. So you can create your own static routes forward traffic to specific destination. Google VPC networks are global and can have subnet in any Google Cloud region worldwide. Okay. Okay. So I hope you guys are clear till now. Okay. So the size of the subnet can be increased by expanding the range of IP addresses allocated to it. For example, this subnet can be interconnected with different regions or different zones. Okay, for example, this is instance or what do you call your virtual machine. Two virtual machines can be allocated within the same subnet. So, and it won't affect virtual machines that are already configured. You can expand the allocation of subnets, but it will not impact the existing configurations. So if the virtual private cloud has two compute engine virtual machines attached to it, it means they are neighbor on the same subnet even though they are different zones. You can see these two virtual machines are in a different zones, US East 1B and US East 1C, but both are configured in the same subnet. Okay, so now let's learn about compute engine. We have learned few things about compute engine in our previous module 1. So it's a infrastructure as a service provided by Google Cloud Platform. Okay, so you can configure your own hardware and software configuration. So what is compute engine all about? It can create and run virtual machines on Google infrastructure. As I said, it's a infrastructure as a service provided by the Google Cloud Platform. You can create your own virtual machines and run Google infrastructure. So there are no upfront investments and thousands of virtual CPU can run on a system that's designed to be fast and to offer consistent performance. Okay, so each virtual machine contains the power and functionality of full-fledged operating system. So every virtual machine has full-fledged power of operating system. What do you mean by that? This means a virtual machine can be configured much like a physical server. So you can select your own machine type or number of CPUs and number of memory, amount of memory you needed. All those things you can configure using the machine type, machine family. So it's as good as a strong physical server. Here you can specify the amount of CPU power and memory needed, the amount and type of storage needed, and the operating system. Okay. A virtual machine instance can be created via Google Cloud Console. Okay. So in GCP console, I'll show you later part. So once you log into Google Cloud Platform, you can create virtual machines. Okay. So GCP console, it's a web-based tool to manage Google Cloud projects and resources. The Google Cloud CLI is command line interface or Compute Engine. Okay. I hope that is clear so far for you guys. Okay, the instance can run Linux or Windows Server image provided by the Google or any customized versions. The virtual machine can run Linux and Windows Server images provided by the Google Cloud or any customized versions of these images. So I hope this is clear so far. So in short guys, virtual machines can be configured same like the physical server that we used to see in earlier times. The strong server with a huge or multiple CPU configured, a huge database size, memory allocation. A similar way you can do it through Google Cloud Console with only few clicks. Third point is you can build and run images of other operating system and flexibly configure the virtual machine. You can choose your own operating system. Okay? So you can choose either Windows or Linux or any other Debian and configure it. Okay. Next, so some Google Cloud Marketplace images are available at no additional cost or charges. Okay. So what is Marketplace? Marketplace, which is a built-in feature or services provided by Google Cloud, which offers solution from both Google and third-party vendors. Okay. So here you can search whatever software you required for your application to support, to develop, or to configure. So as I said, these solutions or softwares comes with no additional costs. Some comes with a additional cost. Okay. And the main part of this is these solutions or softwares or applications, there is no need to manually configure the software. These comes with a built-in execution steps. Only thing is you just need to install software. It automatically get configured on your virtual machines. Okay. All those storage, network settings, everything get configured automatically. But you can also modify them before you launch if that is required. But by default, it comes with the default configurations. Okay, so most software packages in Google Cloud Marketplace are available at no additional cost. The same thing we discussed. The normal usage fees for Google Cloud resources okay, so how do we calculate the usage for Compute Engine? So again, as we discussed in our module 1, the usage in GCP is by billing by per second basis. Okay, but minimum 1 minute usage should be there. Billing is 1 per second basis. Okay. Normal usage fees for Google Cloud resources. Some Google Cloud Marketplace images charge usage fees, but whatever Compute Engine we are using in the GCP, that gets charged, and it charged by per second basis, but it should be having at least 1 minute usage. Okay, so as I said, for all kinds of resources in Google Cloud Platform, to charge per second billing. Okay. For the use of virtual machines, Compute Engine bills by the second with 1 minute minimum, and sustained use discounts starts to apply automatically to virtual machines the longer they run. By default, these sustained use discounts offered by GCP whenever you configure a virtual machine and it starts running. Okay, so there is no need to configure automatically. There is no need to configure manually, but automatically these discounts gets offered by GCP as soon as these machines start running. But these machines should run at least 25% of the time in the month. So Compute Engine automatically applies a discount for every additional minute it runs. Second type of discounts which GCP offers on virtual machines are committed use discounts. This means that for stable and predictable workload. So it means if you are committed to use GCP services for a specific period of time, then the committed use discounts are offered by the GCP. Okay, that means a specific amount of CPUs and memories can be purchased for up to a 57% discount off for normal price. In return for committing to usage term of 1 year or at least 3 years. Okay. So if you are committed to use GCP virtual machines for at least 1 year, next 1 year or 3 years, then there will be additional discount GCP offers, which is up to 57%. Okay, so third type of discount which GCP offers is preemptible or spot VM discounts. Okay. So what do you mean by that? Workload that does not require a human sit and wait for it to finish. That's called preemptible and spot VMs. Here you no need to sit and monitor the job runs. Here you can configure preemptible or spot virtual machines. If you have a workload to be done or batch script to be executed over a night, then you can go for preemptible and spot virtual machines. As I said, such as batch job analysis, analyzing large datasets, you can save money in some cases up to 90% by choosing preemptible or spot VMs to run the job. I hope that clarifies. Let's move on. Next step. Okay, so what all difference between the preemptible or spot VM with the compute engine VM? So the main difference between the preemptible spot virtual machine with compute engine virtual machine is compute engine has permission to terminate a job if its resources are needed elsewhere, but preemptible spot VM, you need to ensure your job can be stopped or restarted. Okay, so whenever any resources are needed, compute engine stops that resource for doing that job and it allocates the resource to some other place. Whereas in preemptible or spot virtual machines, it keeps running. Okay. And what is the main difference between the preemptible versus spot virtual machines? Preemptible virtual machines can only run for up to 24 hours at a time. This is what preemptible virtual machine. But spot virtual machines do not have a maximum runtime. However, the pricing is currently the same for both preemptible as well as spot VMs. Only difference between preemptible and spot is preemptible runs up to 24 hours at a time. This is useful when you want to run a batch job throughout the night for 24 hours without human intervention, and automatically it gets destroyed after 24 hours or stopped or removed. Okay. In that cases, you can go with the preemptible or spot virtual machine. Okay, so there are some more differences which we already discussed. Here are spot virtual machines, preemptible virtual machines. Spot virtual machines have more features than the preemptible virtual machines. So what all more features that we'll discuss in further modules. Spot virtual machines have no maximum runtime, whereas preemptible virtual machines runtime is up to 24 hours. As far as pricing concerned, spot virtual machine and preemptible virtual machines both cost same. So again, finally you will only pay for what you need with custom virtual machines. Okay. Whenever you purchase any virtual machines or configure any virtual machines, then whatever machine type or machine family you use, based on the usage you pay. It means pay for what you need. It's not like a traditional legacy hardware configuration where you set up your hardware irrespective you use or do not use, you have to keep paying the fees or charges for those hardwares. But in the Google Cloud, it's not like that. If you are using only few virtual machines, couple of virtual machines with few configuration, you have to pay only for what you're using. Okay, I hope that clarifies everyone. Let's move on next topic. Okay, so before we move on to the next topic, let's learn more about Compute Engine. Okay, Compute Engine lets you choose machine property. As I said, it let you choose your own properties, your own instances like number of virtual CPUs, amount of memory, by using a set of predefined machine types or creating your own custom machine type. This is what I shared previously. So you can choose your own machine type or machine configuration, machine family. Okay, the different machine types have different configurations. Move on, the scaling part of virtual machine. So virtual machine offers auto scaling. Okay, what do you mean by virtual auto scaling virtual machines? Auto scaling VMs, it means adding or subtracting virtual machines from an application. It's called auto scaling. Okay? So whenever there is a need of additional virtual machines to run a specific application based on the peak usage, for example, during Diwali holiday or Christmas, if your application need more CPU, more machines, more virtual machines, more server to process the more high volume of intake request, then you can auto configure or auto scale your virtual machines as per your requirement. And as soon as the peak hours or peak season finishes, you can, or you automatically your number of virtual machines can come down. Okay, usage can come down and automatically virtual machines gets released. So that's called auto scaling, which is resilient and scalable app. So the other type of virtual machines are large virtual machines, which means instead of adding virtual machines based on the need basis, you can initially configure a large virtual machine itself based on your need. Okay, so you can configure with high memory or compute intensive application. This is used for example, the gaming apps or the gaming applications. We go with the large virtual machines. So here with Computing Engine, you can configure large virtual machines which are great for workload like in-memory database and CPU intensive. Okay, so I hope that clarifies. So auto scaling is you keep adding the virtual machines or deleting the virtual machines based on your peak usage. Whereas large virtual machines is something you upfront configure the large virtual machines with high CPU or high memory based on the what kind of intensive app you want to use. Okay, so large virtual machines or maximum large virtual machines are having maximum number of CPUs per VM, okay, which are tied to its machine family. So there are different machine families or classes we have to, and many more C classes, E classes, where it differs based on the number of CPUs and memory which we are using. Okay, let's go with the learn about VPC compatibilities. So what are different VPC compatibilities we have? First one is routing tables. Okay, so VPC have its own routing tables which are built-in in nature. No router provisioning or managing required. Okay, no router management is required. These are auto configured whenever you set up a VPC, and it forwards the traffic from one instance to another. These routing tables know where to transfer the traffic from one table to another table. Okay. So no external IP address required for this forward trafficking. Second compatibility is firewall. Okay. So here no router provisioning or managing required. Again, it restricts access to instances. Suppose if you don't want specific application to reach out to the specific instance, then you can restrict to a firewalls. You can configure a firewalls and restrict the access, or you can allow access. Either way, you can do it through using firewalls. Okay, and these rules can be defined through network tags. So these two are main VPC compatibilities. One is table routing tables. Second one is firewall. Okay, so VPCs, virtual private clouds, belongs to Google Cloud projects. But what if your company has several Google Cloud projects and the VPC need to talk to each other? Okay, so you want to connect your VPC private cloud network with other cloud or with the on-premises. Okay, in that case, what you have to do, we will learn about that. So there are different ways to connect to different networks using VPC. Some of them are VPC peering. You can perform VPC peering, or you can do it through shared VPC. You can apply identity access some roles, and or through peering, and pair to virtual private clouds, and you can connect. So what is load balancing? So till now we have learned what is cloud computing, virtual machines, okay, and virtual machines compatibilities, tables, firewalls. Now we'll learn about load balancing. Okay. How do your customer gets your application when it might be provided by 4 VMs one moment and by 40 VMs at another moment? Okay. So how do you manage in that case? So that gets managed through load balancing. The job of load balancer is to distribute user traffic across multiple instances of an application. How? By spreading the load balancing reduces the risk that application experience performance issues. Okay, so for example, you have a load balancer and who would like to distribute the user traffic across different instances. Then load balancing is useful. So load balancing identifies which instance the traffic needs to be shared based on the load. So cloud load balancing is fully distributed, software defined, managed services for all your traffic. And because the load balance does not run in virtual machine that you have to manage, okay, you don't have to worry about scaling or managing them. Okay. As I said, Google Cloud load balancing is fully distributed, software defined, managed services. So it automatically distributes software. You have to configure properties, but most of the things it take care by itself. So you can put cloud load balancing in front of all of your traffic. The traffics are like if you have HTTP traffics, web pages and web-based applications, or TCP traffics, transmission control protocol, or SSL, or UDP. So for any kind of traffic, you can use load balancing to distribute the load. Okay. So cloud load balancing provides single as well as cross-region load balancing, including automatic multi-region failover. Okay. So load balancing, it does not restrict itself within the region or within the zone. The load balancing you can perform across different regions and different zones. Okay. So no pre-warning is required for anticipated spikes in traffic. So there is no pre-warning required for Google Cloud Load Balancer to perform its job. It automatically detects the peak or the spike in the traffic, and it distributes the traffic or load across different virtual machines. So, and hence no pre-warning is required. Okay, so VPC offers a suite of load balancing options. You need cross-regional load balancing for web application. Use global HTTP load balancing. Okay. First one is global HTTP load balancing for web applications. And for example, if you have SSL traffic or secure socket layer and not HTTP, then you can go with the global SSL proxy load balancing. If it's other than TCP traffic that does not use SSL, you can use a TCP proxy load balancer. Okay. And if it's upper TCP traffic that does use the global TCP proxy load balancer. So you can use any kind of load balance, any kind of traffics to balance the load. And the two proxy services defined at the end works for specific port numbers, and they only work for TCP. Okay. So if you want to load balance UDP traffic or a traffic on any port number, you can still load balance across a Google Cloud regions with a regional load balancer. It's, for example, if you are having a UDP gaming or data specific load balancing you want to put, then you can go with the regional load balance. Okay, so finally, what all those services have in common? is that they are intended for traffic coming into Google network from the internet. But what if you want to load balance traffic inside your pocket? Okay, so these four are within the internet, but you want to do or perform load balancing within your network. And how do you handle it? This can be done through regional internal load balancing. Okay. So it accepts traffic on a Google Cloud internal IP addresses and load balances it across Compute Engine. I hope that clarifies. So let me summarize. Google Cloud Platform offers a suite of VPC, different load balancing options. First one is global HTTPs, which is used for web application related load balance, and global SSL proxy uses for secure socket layer and not for HTTP. Global TCP proxy uses other TCP which do not use SSL, and regional is load balance across region with specific ports. Example, UDP related traffic. Suppose if you want to perform internal load balancing internal within the project, like between presentation and business layer, then you can perform the regional internal load balancing. I hope that clarifies everyone. So let's continue. Okay, so next one is domain name services, which Google Cloud Platform offers, which is also called as DNS. Okay, so one of the most famous free Google services is 8.8.8.8, which provides a public domain name service to the world. It is freely used across all the projects or services. Okay, so DNS, what DNS does? DNS translates internet host names to addresses, and as you might imagine, Google has a highly developed DNS infrastructure. Okay. Okay, so Google has a highly developed DNS infrastructure that makes 8888 available so that everyone can take advantage of it. Same thing we discussed in our previous slide. Okay, so Cloud DNS, these are managed DNS services that runs on the same infrastructure as Google runs. Okay, having low latency, high availability, and cost effective. The DNS information you publish is served from redundant locations around the world. Cloud DNS is programmable. You can write a program, different languages. You can publish and manage millions of DNS zones and records using the Google Cloud Console or through command line interface or by using APIs. Okay. So what are edge caches? What do you mean by edge caches? Edge caching refers to the use of caching servers to store content closer to the end users. Okay. Suppose if a user is located in the country A, and if frequently user using some content, then those content can be cached or stored in the nearest region. That is called edge caching. Okay, so this will increase the performance or the low latency. Okay. So what is Cloud CDN? Okay. Edge caching. Edge caches, this feature you can use cache the system to accelerate content delivery in your application by using Cloud CDN, Content Delivery Network. Okay. As I said, Cloud CDN is used to lower the network latency. Origins of content will experience reduced load. Okay. Also saves money because the data got cached to the nearest zone or region. So you don't need to again fetch the data from the same database or some other region. It enables with a single checkbox. So how to connect Cloud VPC with other networks? So far we have seen what is VPC, what are its features, compatibilities. Now how do we connect virtual private cloud with other networks such as on-premises or any other private or public network? So Google Cloud provides different mechanisms to achieve this. First one is through IPsec VPN protocol. Second one is through direct peering. Third one is carrier peering. Fourth one is dedicated interconnect. Fifth one is partner interconnect. These are the 5 methods or ways through which your VPC can interact with other private clouds or on-premises networks. So let's go one by one. What is VPN or IPsec VPN protocol? This uses a cloud router to make the connection dynamic. So using the cloud router, you can perform a connection dynamically. Lets other network and Google VPC exchange route information over the VPC using border gateway protocol. So using this border gateway protocol, it lets you connect between the VPN and VPC network. It's not always the best option because of security concerns or bandwidth reliability. So what is direct peering? Direct peering puts a router in the same public data center as a Google point of presence. It uses a router to exchange traffic between networks. More than 100 Google points of presence around the world. Okay. So already there are more than 100 Google point of presence or POP GCP already set up across the world. So you can perform direct peering if you already have your own network and you would like to connect with the Google VPC, then you can go for this direct peering approach. If your system, on-premises system or a cloud system is near to these POPs, then you can perform direct peering. Third one is carrier peering. It gives direct access from an on-premises network through a service provider. Okay. So there is no need to have a router. It provides a direct access to the on-premises network to with your service provider, but it's not covered by a Google service level agreement. Fourth one is dedicated interconnect. Dedicated interconnect allows for one or more direct private connections to Google. Okay. So there are private connections directly allowed to Google to connect. Can be covered by up to 99.99 SF service level agreement. So using this approach, dedicated interconnect, we can achieve 99.99% of SLA, which is service level agreement. So it means there will be no disruption of a service for 99.99% of time, because there is a dedicated or a direct connection between the Google Cloud and your private cloud. Connection can be backed up by a VPN. Okay, so the next one is partner interconnect. It's useful if a data center is in a physical location that can't reach dedicated interconnect co-location facility. Okay, suppose your network is not near the data center, then you can go with the partner interconnect. Okay. So it is useful if the data needs don't warrant the entire 10 gigabytes per second connection. Suppose if you don't want transfer a data of 10 gigabytes per second, okay, and if you're okay to have that kind of connections, you want to compromise in that part, then you can go with this partner interconnect, because the partner interconnect means the different network may or may not have that capability of bandwidth, internet bandwidth. So you may need to compromise in that part, and it can be configured to support mission critical services or applications that can tolerate some downtime. As I said, if the services which can tolerate some downtime, then you can perform interconnection through partnered interconnection. So it can be covered by up to 99.99% SL. Again, it covers 99.99% service level agreement. Okay, I hope you understood what is VPC, what are different cloud DNS and CDNs, content delivery networks. Okay, and you must have understood what is Google Cloud balancing, load balancing. How do we perform load balancing between different machines, and what are different VPC compatibilities, and what is scaling, virtual machine scaling, okay, and Compute Engine and VPC networking. So we have gone through all these things theoretical. So in our module 3, we'll go through some lab exercises and explore the VPC networks. We'll create some auto mode network with firewall rules. We'll create machine instances using Compute Engine, and we'll also explore some connectivity for VM instance. So these all things we'll take it in our next module, which is module 3, VPC and so on, or lab exercise. I hope you like this video. Please do like and subscribe my channel, ITTECHSTACKS with Amar. Okay. Thank you so much, guys.